So, hello everyone, people of the world. In my must-see video I made a few days ago, I made this. Don't know if you recognise it. It was actually an April Fool video, and I said must-see new water molecule structures discovered set to revolutionise biology and chemistry. This was an April Fool, and I actually wrote out April Fool. Nobody's made a single comment. A friend of mine with a PhD missed this. He didn't realise this said April Fool. When he had a second look, he realised what it said. A-P-R-I-L-F-O-O-L. How many of you actually noticed? Because nobody's commented, nobody's liked, nobody's disliked. Maybe it was trying to be too clever. I actually thought it was too obvious. But that was an April Fool joke. When I said that, when I drew out water molecules that were when I said they were these shapes, okay? Actually, this is how water molecules really are. Although we conventionally draw them like this, the angles are not really fixed. That's more of an average, because the bonds are actually, they're like yo-yos. The bonds are all constantly changing length, stretching like a yo-yo. By Hooke's law, okay, force equals k times x, that's a constant. And force equals mass times acceleration, the second law of motion. That's due to Newton, that's due to Hooke. Bonds are continuously changing length, and even these pairs of these lone pairs of electrons they repel each other, so the molecule stays roughly the shape, but it does the actual angle does oscillate a bit. And the whole thing is constantly vibrating. Molecules within our bodies and living organisms are continuously vibrating because the bonds are stretching like an elastic band, and because they're basically like springs. The bonds are like springs, okay? By Hooke's law, and because they're masses and their velocities and accelerations, everything is constantly jiggling about and wiggling about and vibrating. So this is so you do get situations where these actually is more like how they actually reoccur. Sometimes one bond is longer than the other one. Sometimes the angles are more like that. Maybe not quite as extreme, but what I drew is actually more like how they really are. Everything's continuously moving about and vibrating and changing length, and the angles, I mean, that's not going to become... There are occasions when molecules might actually become linear, but it'd be very fleeting when you get the two electrons either side like that. So that could occur, but it'd be very fleeting and very, very brief. We're talking about picoseconds, nanoseconds, or attoseconds. So like a 10 to the minus 12th of a second or something like that, or less. It'd be very fleeting. It could occur because the sort of you get the electrons could get pushed together briefly and then fly apart, and that might flick around, and so they do change shape. Everything's not so. This is generally how they're found, though it's an average, but you will get other structures forming very fleetingly. Certainly in a lot of organic chemistry you often get structures forming like this, which are energetically unfavourable, because sometimes electron pairs get pushed too close together, or sometimes two hydrogen atoms come far too close together like this. This is actually energetically unfavourable because the hydrogens repel each other because they occupy space. And they can't fill each other's space. So a structure like that cannot really exist because the hydrogens repel each other. They're both of volume, and they would sort of knock each other, they would bounce off each other. But you do occasionally get structures like that forming very fleetingly, and then they'll bounce back again to being like this. So in my video, what I said is a new revolutionary structure actually does occur all the time. But I have no idea how many people have actually noticed the joke, the fool. It was 36 views. So I apologise if you were offended that I didn't like it or it was overcomplicated. But yeah, so yeah, by Hooke's law and the second law of motion, force equals mass times acceleration, these structures are actually pretty normal. So yeah, water is, I don't think much has been discovered new about water in the last few years or decades, but yeah, there are some interesting forms of ice though. Anyway, cheers. Please subscribe, help me get to 1,000.